In this video, we're going to put together all the different information we've learned about quadratic functions to describe a lot of information about the graph and then take a look at the graph. Use that information to get the graph. So we'll start, as we almost always do with quadratics, of identifying our a, which in this case is 1, the lead the coefficient of the quadratic term, the b, which is 2, the coefficient of the linear term, and c, which is 1, because we will use these values throughout. So the first thing we're going to take a look at is what's the direction that the parabola opens in. Sometimes it opens up, and that's the case when a is positive, greater than 0, and sometimes it opens down when a is less than 0, a negative number. Now in this case, our a value is positive. So what that tells us is that this parabola opens up. The next thing we'll talk about is the vertex, because the vertex is really the key point for a parabola. It's where it turns around, and the symmetry revolves around that. The range has something to do with the vertex, and also increasing and decreasing. So we really need to know what that vertex is. So we start by using the formula x equals the opposite of b over 2a to find the x-coordinate of the vertex. And for this problem, our b value is positive 2, so the opposite of b would be negative 2 over 2 times the a value of 1. So that would get us negative 2 divided by 2, which reduces or divides to negative 1. Then we can put that negative 1 into the quadratic function, very carefully putting the negative 1 in parentheses. Never hurts, but when it's negative it's required, the two places where we have an x, and then we follow our order of operation to find the value. So negative 1 squared, negative 1 times negative 1 will get us positive 1. A positive 2 times a negative 1 would get us a negative 2, plus 1, and the net result of this would give us 0. So putting this together, our vertex is negative 1 from our x-coordinate up here, 0 for our y-coordinate. So we now have a vertex of negative 1 and a parabola that is opening up. Next, we can easily identify the axis of symmetry, because the axis of symmetry is the fold line right down the middle through the vertex. And the axis of symmetry is always of the form x equals, and it equals the x-coordinate of the vertex. So in our problem, that would be x equals negative 1. And again, that's a vertical line. That would be the fold line right down the middle, where the right-hand side would match with the left-hand side. And next up is the y, or vertical intercept. And we know that the y-intercept occurs in every function, not just quadratic functions, when the x is 0. But when x is 0 in a quadratic function, that would, if you go back to the original function, that would make both the quadratic term and the linear term turn to zeros, and all that would be left is c. So for this problem, our y-intercept, or vertical intercept, is 0, comma, and our c number is 1, so 0, 1. Next, we'll talk about the domain. Not much to say there, because for all quadratic functions, the domain, let's get this in blue, all real numbers. But the range, we know when a quadratic function parabola opens up, it's going to be the y is greater than or equal to the y-coordinate of the vertex. If it opens down, it would be less than or equal to that. So in our problem, our vertex has a y-coordinate, let's go back and look at that, of 0. So our range would be y greater than or equal to 0. That is, the entire graph starts on the y at 0 and goes up. Now if we just quickly sketch this we're talking about, let's see, our vertex was negative 1, 0, so that's like right here. And our vertical intercept, our y-intercept, was 0, 1. It's opening up, so we have something that looks like this. We'll look at a better graph in a minute, but that's a quick sketch. So in order to talk about increasing and decreasing, we're talking about the x interval where this graph is increasing. And I think you could see that the part of the graph that's increasing is right here, the right side of that graph. Keep in mind that we have that axis of symmetry, the fold line, right down the middle there. So we're talking about the right side. So if that point is negative 1, 0, for increasing, we're talking about all the x's that are greater than negative 1. Not equal, because at negative 1, it's turning around. It's not going up or down. It's that vertex or turning point. Now decreasing would just be the other side. So the left side, which means that we're talking about all the x's less than that same number, negative 1, okay, in order to see the left side of that. Okay, so we can just take a look at our sketch here to talk about the x-intercepts. Now normally there are 2, but if you'll notice on our graph, there's only one place where this parabola touches, doesn't cross-touch our x-axis. And that's because this is a somewhat unusual problem because of the nature of the algebra, but the x-intercept, just the one, would be the same thing as our vertex, negative 1, 0. So when that turning around point is on the x-axis, we only have one x-intercept. But we could typically have 2, or it is possible to have none. But in this problem, our x-intercept is negative 1, 0. Now, if we put this all together on a graph, we could see how this graph emerges. So we'll start by graphing the vertex, negative 1, 0. And then our axis of symmetry, I'm actually just going to kind of put a dashed line. And I'm only going to put it above because we know this graph opens up, the parabola opens up, so there's no sense in drawing it any further than that. We also have a vertical or y-intercept of 0, 1. So we have that point. And we can notice that that point, 0, 1, is one space to the right of the fold line. So in our 2 for 1 cell, we actually get 2 points for the work of 1. So we also have another point on the other side of the fold line, to the left of the fold line, at 1. And so right now, we really just have those 3 points. To get a better sense of shape, we might want to do a little more calculation to get some more points. But for now, we know, as we saw in our sketch earlier, this parabola will look something like this. Well, let's take a look at a little better graph than my handwritten sketch. So using a little bit of technology, we can put this graph on a grid and see a much better looking picture of it. And we can confirm all the information that we discussed. So that's using all the information we can pull out of a quadratic function in order to get its graph.